There's a string. Mean position. Two lines. I started from the first diagram. Let me have some more reference lines. It'll be easy for me. Antinode. Node. Okay, this we have like this. So let me show the shape of the string. It's a sine wave. After some time, this will become maximum, no? Yeah. It's a wrong one. I'll put it. It will go to the lower extreme. Yeah. And finally, it will come to mean position. This last one. We'll stop it till here. This will be sufficient to explain things. Okay, I have complete description. Complete set of string. So I'll start from here. So this is the node red color I'm putting. What is the node which will never vibrate? And we have next the antinode. Not reflecting color, I'll choose some other thing. It's just a practice of this one. There are some symbols what they used. Circle dot node, circle cross will be antinode. This will be easier for us, that one. So now this same antinode, this is a node. Okay, then antinodes will represent here. Okay, there's a string. Now, according to this, there's antinode. So what is antinode? Which can have displacement equal to 2a. Now it is in one position. Let's assume that one. What makes it to move down? How the tension will act here? We know already traveling with the tension should act vertical. So it will make it to accelerate. So when it is accelerating, so we do get this one, the velocity will represent by this one. So this will be the velocity. Velocity of, so here I can show clearly. Okay, fine. No, again, it will be moving down. The length of the arrow will indicate the magnitude, just for our convenient purpose. And they have come to finally extreme position. From extreme position, again, they'll be moving up. You try to see this. moving up, no? I'll just make some small. This diagram very important. It speaks total chapter. The total chapter, what all we wanted to share, that information is available in this diagram. Let me put once again. That's why with the utmost care, I'm trying to, because instead of speaking lot, no, so the diagram what I'm trying to dump maximum information. You can pick up any arrows just to show that point. Different points will have different speed. Okay, this is what the then we can move here. This is one more last. The rope is here, so it should move up, no? Okay. This will have maximum speed. Okay, let me get into the explanation part. It took more time. This is what happens in the to that particular string. You can try this at home. You take one string and connect between two walls and try to vibrate. No, we do get the shape of the rope like this here. Okay, let me get into explanation. All of you are able to see the rope, everything simple. So I'll bring this one. So now let me start from here. So what make this antinode? This antinode, no, the symbol antinode. And what about this? Here it is. Okay, this will be node. Standing wave, please do remember this diagram, that equation. That is enough. Any theoretical question you can manage, any conceptual question. Now, what make this antinode to move down? The component of tension will act here, so it will accelerate. We know when a particle is executing SHM, when it moves from extreme to mean, what should happen to its speed? Should increase. So its velocity keeps on increases. Who will increase? The tension. So here I'm showing velocity. Then what about velocity of this? So the velocity of this will be slightly less compared to the other one. So who will have maximum velocity? The antinode will have maximum speed. Then finally what happened? When the string becomes horizontal, then so what happened antinode? It will have maximum speed. All points on the string means all points mean leaving this node. So all these points what happen? They are at their maximum displacement. All points cannot have amplitude equal to 2a. So you look at this. There's the maximum displacement of antinode. How much equal to 2a? What about this? The maximum displacement of this will be less than 2a. So we'll have maximum displacement equal to amplitude of standing wave. The antinode only. Only antinode is permitted to have maximum displacement equal to amplitude of standing wave 2a. What about this? This point also will execute SHM, but what is its amplitude? Its amplitude will be less. So here, so what type of string we are seeing now? We are seeing the points on a string where different points will have different amplitude, but all will have same time period. Are you getting? There's a golden statement. You move from node to antinode. What is the amplitude? I'm saying amplitude. What is amplitude? Maximum displacement from mean position is different for different points. But what about time taken will be same. All will take same time to complete one oscillation again. So you look at this antinode and this point, both will take same time to come to mean position. So how much it is time? So this, if I define t equal to 0, what is this? This is t equal to t by 4. So what is the time taken? The same time. But what about their amplitudes will be different. So at this antinode, you can see antinode is having maximum speed. Of all among antinode will have the maximum speed here. No? Next, again, look at this. Either side of antinode, how the particles will be moving in same direction. Will agree. So this is an antinode. No, on either side of antinode, the particles will be moving in same direction. Look at the node on either side of node. How the particles will be moving? They'll be moving opposite to each other at all the time. Now also, this point will be moving up. Very good conceptual question they'll ask you. So you must know just this diagram. That's all. Nothing big. You look at on either side of node how the particles will be moving. They'll be moving opposite to each other at all the time. You check it. Now all points on the string are at rest. So what is this time? This time will be t equal to t by 2. This is t equal to 3t by 4. Again, after this, what happened? We'll get this particular thing. So like this, it'll be one oscillation. So therefore now how you can say this will be node, this will be antinode? Why can't this be node, then antinode, some design? Why they should be alternate? Okay, I have mathematics. You look at the position of node where it is lambda by 4. If I say this x equals 0, this will be x equal to lambda by 2. How do you can say what is the distance between adjacent nodes? Lambda by 2. Lambda. What is the distance between adjacent nodes? Lambda by 2. I'm saying what is the distance between adjacent nodes? It will be lambda by 2. What is the distance between adjacent antinodes also? Lambda by 2. So after node, what do we get? I think please do look at the mathematics. This is very important. First, I'm starting x equals 0. This is node. Next, after this, what you should get? Sir, why can't be antinode here? No. X equal to next node where it will be lambda by 2. No, between node to adjacent nodes, there should be a antinode. How do you can say 0 x equals 0 node, x equal to lambda by 2 node? X equal to lambda by 4 will be antinode. So therefore, I'll call this as 1 lambda by 2. This distance, what happened? We'll call it as, this is very important. And what about this distance? This will be lambda by 4. Distance between adjacent node and antinode will be lambda by 4. Distance between adjacent nodes will be lambda by 2. Like that, what happen on a string will get nodes, antinodes, node, next antinode. Again, what is the distance will be lambda by 4. So where the next node will be located? This will be 3 lambda, 3 lambda by 2, 2 lambda, lambda by 4, antinode, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4. Like that, the position of antinodes will be available. So in this way, what happen? We will get a node signed antinodes. And what's happening to the who are executing SHM? Nodes, antinodes, or points other than node antinode. I think there are 3 categories are there no here. Nodes, antinodes, and points other than node antinode. Who are executing SHM? Other than nodes, all points are executing SHM. Okay, fine. There's a one point. After this, next again. Then who will have amplitude equal to amplitude of standing wave? Only antinode. Okay, got this? Then next, how the points on either side of antinode will be moving? They'll be moving in same direction. So what is the phase difference between them? Will be zero, no? The points on either side of node, how they'll be? At all the instant, they'll be moving opposite to each other. So what is the phase angle between them? Will be pi radian. There's another point. Next again, after this, who can have maximum speed in this one? Antinodes only when they're at mean position. Different points will have different amplitude, but all will take same time to complete one oscillation. Okay, let's come for some energy aspect. Shall I say here potential is maximum? I will write on this side. For this case, U is maximum. Kinetic will be 0. What about here? U non-zero, K non-zero. Here what happened? K max will be non-zero. Kinetic energy will be maximum. I'll write it. I'll check once. I'll check it. So here K will be maximum. U will be 0. Here both will be non-zero. Standing waves you can have. It all depends upon the frequency, no? The lambda, all that one. On a given length, you can have any frequency of standing wave. Okay, I agree this. So these are the some writing. Let's come to the energy aspect also. Okay, let's talk about for this string. Who is having maximum kinetic energy? Antinode. And what happened to the speed of points as I move from antinode to node will decrease. So therefore, if I move from node to antinode, kinetic energy increases. That depends upon frequency of source, no? That I'll come later on that one. First year. So as I move from node to antinode, what will happen? Kinetic energy will increase. Will agree. So what do this length of arrow indicate? The speed. Antinode will have maximum speed. This one, as I move from node to antinode, what happened to speed of the points on a rope will increase. Here, kinetic energy will increase. As I move from antinode to node, the speed will decrease, kinetic energy decreases. Okay, now, so among all, who will possess maximum kinetic energy? Antinode. Okay, fine. Let's talk about the potential energy. The potential energy is nothing but slope, no? Where slope is maximum, here slope is 0. Slope is maximum here. So what happened here? The node will possess maximum potential energy. What about points other than node antinode? They will have both potential as well as kinetic energy. Am I right? Look at the slope non-zero. Potential will be there. And also you look at the kinetic energy. They're having a speed. So what is the conclusion now here? So as I move from node to antinode, potential energy what happens? Decreases. And at antinode will become 0. Where potential energy maximum? At node. And will be 0 at antinode. Kinetic energy is maximum at antinode and will be 0 at node. What about points other than node antinode? they will have both potential energy as well as kinetic energy. I think we have to categorize string into three parts. One, node, antinode, and the points other than node antinode. Antinode will possess only kinetic energy. Node will possess only potential energy. What about other points? They will have both potential as well as kinetic. Got the idea? This one, this about the energy aspect is what I'm explaining here. Okay, let's summarize all this point. Any doubts you have, you can ask it. Now, let me one final conclusion. If I'll increase the frequency of the wave, who will increase frequency? The frequency of incident, this one. See, well, I'll send a traveling wave. It will get reflected. Continuously, I'll send a traveling wave. Continuously reflected will come. Both will undergo superposition. Then we'll get this one. So what is the condition for a standing wave to form? Both the waves of same speed, same frequency of amplitude may or may not equal, moving opposite to each other, undergo superposition, will get a standing wave. I think that's what the condition you see that one. How YR is towards left, not towards right. Two traveling waves of same frequency, same speed, moving opposite to each other, undergo superposition, will get a standing wave. Who will determine frequency? The incident traveling wave. Okay, now I'll increase the frequency. Then what will happen? I can see that at higher frequency, how do this appear? This will appear like a loop. Am I right? I think you look at the fan. Fan will have only three wings. As it rotates, how do it appear? It will appear like a this, no, almost like a rotating disc. The same thing here. If this wire vibrates at higher frequency, then what will happen? You can see that instead of seeing a wire, what you see, you can see a loop. That is what the representation of standing wave. How we represent a standing wave? The standing wave is represented. Don't think again there are two wires are there. There's only one wire.